chain of events, cause and effect. We analyse what went right and what went wrong, as we discover that many outcomes can be predicted, planned for, and even prevented. I'm John Chidgey, and this is Causality. This episode is brought to you by Manytrix, makers of helpful apps for the Mac. Visit manytrix.com/pragmatic for more information about their amazingly useful apps. We'll talk more about them during the show. Causality is supported by you, our listeners. If you'd like to support the show, you can by supporting our sponsor or by becoming a premium supporter. Premium support is available via Patreon and through the Apple Podcasts channel subscription. Premium supporters have access to early release, high-quality, ad-free episodes, as well as bonus material from all of our shows, not available anywhere else. We're edging closer to our monthly goal to go advertising-free across the network, but we can only do that with your help. Causality is also a Podcasting 2 enhanced show, and with the right podcast player, you can also stream Satoshis and boost with a message as you listen. Visit engineer.network/causality to learn how you can help this show to continue to be made. Thank you. Triangle Shirtwaist Factory. In the early 1900s in the United States of America, there was a demand for mass-produced clothing, and the more fashionable the garment, the better the profit, which led to a high demand for clothing manufacturing. With material costs being high, the most effective way to make money in the industry was to employ staff for as little as possible, and New York had a large influx of migrants looking for work. With a flood of people comes lower average wage expectations, and with the local supply chain and overseas manufacturing and shipping far from becoming a viable economic option in 1900, this drove onshore or local production as a necessity and put New York as a prime location for mass clothing manufacturing. Over 2 years, 1900 and 1901, a 10-story building was constructed in the Greenwich Village neighborhood at 23 to 29 Washington Place, near Washington Square Park. The building was named the Ash Building after its owner, Joseph J. Ash. The building itself was unremarkable in most respects, but it was ahead of its time in others, with some outward opening doors for ease of egress during an evacuation, for example, and it attracted several companies as potential tenants, including the Triangle Waist Company, or TWC for short. The Triangle Waist Company was a partnership between Mr. Max Blank and Mr. Isaac Harris, and in August 1901, they established a factory to manufacture shirtwaists, with an initial 30-month lease for the 8th floor, which was later extended and spanned the top 3 floors of that building. A shirtwaist was the name given at the time to a lady's garment, called a blouse, in the style of a shirt with a turnover collar and cuffs, as well as a front button closure for women. At its peak, the factory employed approximately 500 people, and they were predominantly women and older girls, recent migrants, and the workers weren't especially well paid, even for the time. The rooms were organized into multiple long rows of wooden tables, without breaks between those rows, that is to say, there was only one aisle at the end of the table, to make the most economical use of available floor space. The process for manufacturing the shirtwaists was an assembly line of sorts, with one of the stations for cutting the larger fabric pieces into the design required based on a pattern. The patterns used for each design were made from a light tissue paper and were hung from clotheslines above the cutting stations for ease of access. Waste from the cutting stations was kept beneath the cutters' tables in wicker baskets, and these baskets were generally emptied once they were full, a process that could take 2 to 3 months depending upon the productivity of the cutter in question. The cut-to-size pieces of fabrics were passed on to the next station for further stitching and eventually checking and then finally for packing. The cost of the materials to make the shirtwaists made the source materials, as well as the finished items, attractive as something that was sometimes stolen by the underpaid staff. To combat that theft, the supervisors would regularly lock the primary exit door to the main stairwell during the working shift, and upon exiting the building, the staff were required to submit their bags for inspection prior to leaving. Talking and singing were not permitted during work hours, and toilet breaks were all monitored. The oil used for the machines was often spilt and was generally found all over the floor, and that would mix with dust and stray threads. It was a crowded and unpleasant environment to work in. There's no doubt about that. In fact, in most respects, the factory fit the Britannica definition of a sweatshop, which is a workplace in which workers are employed at low wages and under unhealthy or oppressive conditions. So with that background, let's talk about the incident itself. At approximately 4:40 p.m. local time on Saturday afternoon, the 25th of March, 1911, and with only 20 minutes remaining in the workday, a fire was noticed in a scrap of offcuts basket underneath a cutter's table on the 8th floor in the northeast corner. Workers first used buckets of water in an attempt to fight the flames, however, were unsuccessful. There was no fire sprinkler system installed as these weren't required by law, but there were fire hoses attached to a common standpipe throughout the entire building. A manager fetched a fire hose from the wall only to find the hose itself had partly rotted and wouldn't carry much water to the nozzle. Even so, the supply valve had been rusted closed, and it was of no use at all. At approximately 4:45 p.m., a passerby raised the fire alarm, and the fire department were dispatched for assistance shortly thereafter. Workers on the 8th floor made for the elevator and the fire stairs, and the company bookkeeper, who worked on the 8th floor, called the corporate offices on the 10th floor and informed them about the fire before making for the exit. Several people who couldn't fit in the elevator or reach the fire stairs or fire escape chose to jump out of the windows in an attempt to escape the rapidly spreading flames. By this time, no one had contacted approximately 260 workers on the 9th floor, and even when many had already escaped from the 8th and 10th floors, the closing bell was sounded on the 9th floor with no one aware of the fire happening on the floor beneath them. The workers on the 9th floor were mostly collecting their paychecks and grabbing their coats from the cloakroom on the Washington Place side of the building when the first flames started to come into the floor through the external windows. In a very short space of time, the fire had encircled the building at the 9th floor, and when the workers attempted to escape via the main stairwell, they found that the doors at the Washington Place exit were still locked, as they had been since the start of the shift. The fire spread quickly through the floor, with patterns, fabric, and oil fueling its progress rapidly. A foreman that had the key to that door had already fled and escaped, without thinking to unlock the door first. The two internal exits were to Green Street, which had roof and ground level exits, and Washington Place, which only had a ground exit, so some of the staff moved towards the Green Street exit. The long benches made movement from one side of the floor to the other very difficult, with those clambering over the tables often falling as they were so cluttered with garments and equipment, and access to the Green Street exit was also partly restricted due to stacked boxes that had been stored near it. Despite this, some did make that exit, which wasn't locked, and made for the rooftop. As the fire intensified near the machine oil storage barrel, it exploded and blocked this exit as well, cutting off that line of escape. Not many of the staff were aware that there was an external steel fire escape that provided another path to get out, as the windows on the courtyard side of the building were often shuttered and closed. However, some people realized there was another escape option and pried open the shutters. As more and more people came out onto the external fire escape and gradually made their way down, the structure began to shake under the weight of the people. The few that made it to the lowest level of the steel fire escape found that where there was supposed to be a ladder, there was nothing, and it was still too high to drop safely to the ground without one. The heat from the fire further weakened the steel structure of the steel fire escape, and ultimately it fell off the side of the building to the ground with approximately 20 people still on it. The people that had successfully made it to the roof were assisted by students from the adjacent New York University main building, which was slightly higher than the Ash building, but they lowered ladders and helped lift people to safety. Inside the building, the only remaining exit path was the elevator. Elevator operators Joseph Zito and Gaspar Mortellaro made 3 complete trips to the 9th floor to pick up passengers. Ultimately, though, the rails of the elevators buckled under the heat from the fire, and once they had stalled, desperate people attempted to escape by sliding down the elevator cables, trying to land on top of the elevator cars. Many of them lost their grip and fell. With no exits remaining now except the windows, many tried to hang down the outside of the window, holding onto the ledge and to wait for rescue, whilst others simply ran and jumped. The choices were jump or burn to death. In total, 62 people either jumped or fell from the building during the course of the fire. The earliest people to fall created difficulty for the first fire engines reaching the scene to get close enough to the building to deploy their ladders and catching nets. When the fire department did finally deploy their ladders, they could only reach the 6th floor, too low to be of much use, and when they deployed their catching nets, the nets weren't strong enough to withstand the force of a person jumping from that height. When people fell, they simply ripped a hole in the net and fell to the pavement anyway. 123 women and girls and 23 men, that's 146 people in total, died. Most of the victims had died of burns, asphyxiation, blunt impact injuries, or a combination of them. Interestingly, both of the factory's owners were actually in the building at that time with their children. They escaped via the roof. During the investigation, and despite the ban on smoking in the cutting room, the fire marshal concluded that the most likely ignition source for the fire was an unextinguished match or a discarded cigarette butt. There had been a long history of cutters sneaking in cigarettes and disguising the smoke by breathing out through their clothing. Another potential ignition source was the sewing machine engines, but also arson. However, these were less likely, and arson was officially ruled out following the incident investigation. In October that year, the New York City Board of Aldermen created the Bureau of Fire Prevention. And on the 30th of June that year, the New York State Legislature established the Factory Investigating Commission, or FIC for short, headed by Senate Majority Leader Robert Wagner. And from October that year through to December the following year, it held 59 public hearings, took testimony from 472 witnesses, and it investigated 3,385 different workplaces across 20 different industries. So what went wrong? You could argue that almost everyone on the 8th and 10th floors escaped, but the majority of people that died were stuck on the 9th floor. The two primary reasons so many died on the 9th floor: 1, the door was locked, and 2, they had no warning. With more warning, they could have more easily used the Green Street exit to escape in time. With both exits available, even with the same amount of warning, they could have escaped via both exits in the time that they had available. But it's not quite that simple, since the building itself was supposed to have been better designed. The owner of the building had made claims that the building was in fact fireproof. Of course, there's no such thing as something being fireproof. The definition of fireproof is that something is, and I quote, proof against or resistant to fire, end quote, which really, honestly, the building isn't and wasn't. If you can have anything that can burn at a given temperature, then it will burn if given enough heat. Fires, unfortunately, are the inevitable outcome of living in an environment where oxygen makes up a fifth of your atmosphere. So, literally speaking, they don't mean the building was fireproof, but rather they claimed it was better equipped to handle a fire should one happen. But I digress. The basis for that fireproof assertion was, at that time, there was no law that required fire sprinklers or outward opening doors, of which some of the doors were outward opening in this building. It's just that one important one was locked. That said, the building architect, Mr. John Woolley, had originally intended to have 3 internal stairwells for improved capacity during an evacuation, which was required under separate legislation at the time for buildings with 10,000 square feet or more of floor area. However, Mr. Ash contended that the external fire escape would be sufficient as a third point of egress under an evacuation scenario, and permitted only 2 internal stairwells be built. The external stairwell, however, wasn't complete, it was missing a ladder, and structurally it wasn't sound either. So why push back on a third internal staircase? A simple enough answer was because of floor space. You can't rent out a stairwell, but you can rent out and charge for the floor space that it would have taken up. Let's talk a bit about building responsibilities. The responsibility of the building having sufficient firefighting equipment and egress points in case of a fire is that of the building owner or administrator. Anyone that is renting, letting, subletting, occupying the building is responsible for ensuring that their employees are familiar with evacuation routes and in the use of firefighting equipment, and to know where it's installed. Given that in the entire decade that the Triangle Waste Company had occupied 1 or more floors of the building, there was no recollection or records that existed that a fire drill had ever taken place, and that was a clear act of negligence by the TWC. Having said that, they did try to use the fire hose, but they couldn't turn it on, and the hose itself had been damaged. Thinking about it, that fire hose was only 10 years old, and whilst this was 1900, the water quality might not have been the best and the fittings might not have been correctly selected or installed. A correctly installed and stowed fire hose of that era would have degraded somewhat, but should still have been usable even after 10 years, which suggests that it probably wasn't stowed correctly. But either way, a regular test of that fire hose and fire valve would have highlighted that the valve corrosion was a problem and the hose could have been replaced at very little cost. This episode is brought to you by Manytricks, makers of helpful apps for the Mac, whose apps do, well, you guessed it, many tricks. Their apps include Butler, Keymao, Leech, Desktop Curtain, TimeSync, Usher 2, Menuware, Moom, Name Mangler, Witch, and Resolutionator. There's so much to talk about for each app that they make, so we're just going to touch on some highlights. Usher 2, the return of the classic Usher, but now it's a full 64-bit app that works with the latest versions of macOS, including Monterey. So what is Usher? It's an amazing, powerful media management and playback app that can see movies you have in TV, music, and Photos apps or any library location you'd prefer on your Mac. It can organize them for you if you like. You can create advanced playlists and sorting criteria, and you can even edit their information all from within Usher. Menuware puts your Mac's menu anywhere, well, wherever your mouse pointer is. It's such a simple idea that is so very handy. Instead of having to mouse up to the top of the screen, press a hotkey of your choice and Menuware puts the menu right where your mouse is. You show the current active apps menu or the entire menu, then you pick your app from there if you prefer, and as another bonus time saver, you can even hide the menus that you rarely use. It's a great time saver for me, and I bought it within a minute of trying it because I saw the value in it immediately. Moom makes it easy to move any of your windows to whatever screen positions that you want. Halves, corners, edges, any fraction you like of the screen. And then you can even save and recall your favorite window arrangements with a special auto-arrange feature when you connect or disconnect an external display. It has full touch bar support and keyboard integration with Adobe's apps, and it also works perfectly on an iPad operating in sidecar mode. It's the first app that I load on a new Mac because it's just awesome. Name Mangler. You've got a whole bunch of files to rename quickly, efficiently, and in large numbers? Well, then Name Mangler can help. It's designed for staged renaming sequences with powerful regex pattern matching. Recent additions include a group by feature. When making a sequence, and title case conversions can now keep their existing formatting or convert to lowercase on word length. The best part is, it shows you the result as you go, and if you mess something up, just revert back to where you started and try again. Witch. You should think about Witch as a supercharger for your Command Tab app switcher. If you've got 3 or 4 documents open at once in any one app, then Witch's beautifully simple pop-up quickly lets you pick exactly the one you're looking for. You can switch between tabs as well as apps and app windows with horizontal, vertical, or menu bar switching panels. With text search for switching, you can show the frontmost app in the menu bar icon with full touch bar support and much, much more. And finally, Resolutionator. And it's so simple. A drop-down menu from the menu bar, and you can change the resolution of whatever display you like that's currently connected to your Mac. The best part, though, you can even set your resolution to fit more pixels than are actually there. It's very handy when you're stuck on your laptop and you need more screen real estate. Now, that's just 6 of their great apps, and that's only about half of them, and they all work with the latest version of macOS Monterey. All of these apps have free trials that you can download from manytricks.com/pragmatic, and you can easily try them out before you buy them. They're all available from the website or through the Mac App Store. However, if you visit that URL, you can take advantage of a special discount off their very helpful apps exclusively for Engineered Network listeners. Simply use Causality25. That's Causality the word and 25 the numbers in the discount code box in the shopping cart to receive 25% off. This offer is only available to Engineered Network listeners for a limited time, so take advantage of it while you can. Thank you once again to Manytricks for sponsoring the Engineered Network. Something that isn't covered as much regarding this incident were the shortcomings of the fire department in New York at the time. The units that responded weren't able to reach any building higher than the 6th floor. In the mid-1850s, New York firefighting was still predominantly done using leather buckets passed person to person, but by the turn of the centuries, the buildings had become taller as real estate in Manhattan had become increasingly scarce, and the only way to grow was to build upwards. This required steam-powered pumps and hoses that could handle the additional water pressure to reach fires that were now much higher above the ground. The buildings were approved to be built higher and higher without enough consideration for how those fires could be fought by firefighters from ground level. The ladders were too short, the nets for catching people falling weren't strong enough to handle a fall from greater than the 6th floor either. And the point is, when you're pushing the boundaries of what's possible under normal conditions, you have to consider how to handle the exceptions. It's a theme we see over and over again with new technology. Keeping in mind this was 1900, historically it hadn't been possible to build a building that tall, so taller buildings could be considered a new technology in civil engineering, at least at that time in history. When they did build it, they needed to consider the evacuation requirements far more than they did. For those that think there's nothing new in civil engineering, maybe there is. Think about the Burj Khalifa in Dubai. At the time of recording, that building is the tallest in the world, standing 160 stories high in total. During the risk assessments, they determined that it was unrealistic to expect that people could walk down that many stairs during an evacuation scenario, and hence they rethought fire survival, and instead they installed pressurized, air-conditioned, fireproof refuge rooms every 25 floors, give or take a few, designed to be fully isolated so that people could await rescue. It's a similar method to long tunnel designs, where they have rescue rooms every so many hundreds of feet within them. Of course, the counter-argument is people could be stuck in there for too long. They could run out of oxygen, the building could buckle and fall under extreme heat, and it could collapse. So if you need to get out in an emergency, maybe your best option is to simply not make buildings that tall, or tunnels that long or deep. And why don't people think like that? It annoys me. Let's talk about the aftermath. For the building following the incident, outwardly the building had sustained minimal damage due to its construction. However, it was repaired internally and retrofitted in several areas. The Washington Place staircase was made accessible to the roof. A new external fire escape was added that now extended across the full width of the courtyard exposed side, and this one had a ladder too. The iron shutters over the courtyard windows were replaced with wire glass windows. 2 large water tanks were also installed on the roof to hold firefighting water and were part of the new sprinkler system. The building was renamed the Greenwich Building, and for several years it continued to be used for manufacturing. Towards the end of that decade, the New York University leased space in the building, installing a library and some classrooms, and by the end of the 1920s, the university occupied a significant part of the building. Philanthropist and realtor Frederick Brown purchased the building on the 28th of February 1929 and signed the building over to the New York University, who still own and occupy it to this day. Let's talk about the impact to legislation. The Factory Investigating Committee recommended 28 bills to the legislature in 1913, of which 25 were passed into law, including requirements for buildings to have fireproof stairways, doorways of a minimum width, improved lighting requirements, more fire-resistant building materials, safer construction of fire escapes, and requirements for retrospective inspections of older multi-story buildings. Laws were also made more strict regarding the treatment of employees. On the recommendations of the Investigating Commission, the New York City Building Code was significantly revised in 1915 and 1916. For the first time in the United States, hard limits were set for the occupancy of buildings based on the capacity of emergency exits. The Buildings Department were given the right to inspect, fine, and order repairs to non-compliant buildings relating to fire requirements, amongst other things. The legislation, in fact, set the tone for sweeping changes throughout America in the years and decades that followed. I want to talk a little bit about Frances Perkins. Frances witnessed the Triangle Fire and was a member of the FIC. She was a social worker and a reformer and ensured that the committee personally walked in the shoes of the workers in the 3,000-plus workplaces they inspected. She ensured that Robert Wagner himself attempted to use the external fire escapes with impossibly high ladder drops, crawled through exit holes in the walls of the buildings, and saw children as young as 5 years old working in sweatshops of the time. In later years, she became the first woman to be appointed to a cabinet post when she was appointed Secretary of Labor by Franklin D. Roosevelt. Federal labor regulation in later years, the so-called New Deal era, from which the minimum wage law came, Frances later in 1932 said, and I quote, "The New Deal began on the 25th of March 1911, the day the Triangle factory burned." End quote. Briefly about TWC, the business. On the 30th of March 1911, the business was reopened in a different building on University Place, and they became an incorporated business in July that year in an attempt to separate the business from themselves personally, a common practice to isolate individuals and protect them from civil lawsuits. The insurance claim of $200,000 was enough to stage a recovery of sorts. However, the business ultimately didn't see out the decade and closed permanently in 1918. As for the owners, and despite the laws introduced twice in 1913, in August and again in December that year, Mr. Max Blank was fined and reprimanded, having been caught locking employees in during work hours. Again. 23 civil lawsuits were brought against the TWC owners during 1911, which Mr. Harris and Mr. Blank settled, paying $75 per life lost, which today is about $2,000 per life lost. Having said that, the families that had filed lawsuits were generally unable to pay their legal costs. Thinking about that just for a second, with 146 lives lost in this incident, that's a total payout of $10,950 US at the time. Now, given that the insurance payout was $200,000 US, well, that's just what, 5% of that total? I mean, what? Mr. Harris and Mr. Blank were also accused of criminal negligence, and the trial went for 8 months, and the jury could not agree that the owners were aware of the locked door on the 9th floor, and hence they were found not guilty. The court transcript makes for some interesting reading and certainly raises some questions about whether the judge influenced the jury and whether key witness testimony was dismissed with a somewhat, you might say, flimsy argument about a precisely recited account of what happened, or that's how it was framed. But this isn't a law podcast, so draw your own conclusions about potential miscarriage of justice on your own time. This is about engineering. When you work in the construction industry, you learn very quickly about fire regulations. When I was a young engineer, I was sometimes annoyed and frustrated when more experienced people made me move boxes and chairs and debris away from doorways. Ensuring that there was always a clear, unobstructed walkway free of debris, even during construction, it was a big deal. But the point is that those people were protecting my life and everyone else's. In the event of a fire, I would be able to escape because we made sure everything was clear of the exits. Same kind of thing with fire drills. How many times have you been in a building, trying to buy something from a shop, in an important meeting, trying to get something done, and you just don't have time, and the fire alarm goes off? It's a drill. And you think, oh, great, that's just what I need. But the point is that, well, yeah, they're annoying, but you need to have them. It's better that you go through the drill today and learn where everything is than to wait until there's an actual fire and you need to get out in a hurry. Fire drills aren't also just about you and you learning, it's about the entire building and organization learning as well. So maybe it's not about you learning alone, it's about everybody learning and making sure that it works smoothly if the worst happens. It's also to confirm that egress pathways are clear of obstacles and everything is still open and ready. And making sure firefighting equipment is within date and regularly tested is just as important. For people everywhere, fire blankets, fire extinguishers in your own home, you should be checking that they're within their usable date so that you know that they're going to be ready if you need them. All I hope for when there is an incident like this one that was so completely preventable, so easily predictable, and yet it still happened, is that something is learned from it in the end so that it's less likely it will happen again. So the next time you hear that there's a fire drill, remember why you're having that drill. The next time you walk past that fire extinguisher, just take a second and just check the inspection date. If it's out of date, maybe do something about it. When profit is the focus and we pretend that nothing will ever go wrong and safety isn't a priority, if you give it enough time, it will always end badly, and someone will ultimately get hurt. So if you're ever in a position where you're responsible for the safety of people in a business, the cost of holding a fire drill and testing the equipment is immeasurably insignificant compared to the cost of failure when it all goes wrong. I'd personally like to thank Manytricks for sponsoring the Engineered Network. If you're looking for some Mac software that can do many tricks, remember to specifically visit this URL, manytricks.com/pragmatic, for more information about their amazingly useful apps. If you're enjoying Causality and want to support the show, you can by supporting our sponsor or by becoming a premium supporter. We're edging closer to our monthly goal to go advertising free across the network, but we can only do that with your help. You can find details at engineered.network/causality to learn how you can help this show to continue to be made. A big thank you to all of our supporters. A special thank you to our silver producers, Mitch Bilger, John Whitlow, Kevin Kosh, Oliver Steele, Leslie Law Chan, Shane O'Neill, Hafthor, Jared, Bill, and Joel Marr. And an extra special thank you to both of our gold producers, Stephen Bridle and our producer, known only as R. Causality is heavily researched, and links to all materials used for the creation of this episode are contained in the show notes. You can find them in the text of the episode description of your podcast player or on our website. Causality is a podcasting 2.0 enhanced show. With the right podcast player, you'll have episode locations, enhanced chapters, and real-time subtitles on selected episodes, and you can also stream Satoshis and Boost with a message if you like. There's details on how, along with a Boostagram leaderboard, on our website. You can follow me on the Fediverse at Chidgey at engineered.space, on Twitter at John Chidgey, or one word, or the network at engineered_net. This was Causality. I'm John Chidgey. Thanks so much for listening.